So let me give you a quick overview about the homework on homework number 3. Here's the problem from the book. What you want to do when you work on these problems is take a look at the big picture. What features are shown here that give you an idea about what the water is doing. So here's Lake Michigan, and these are rivers that flow into the lake. So this river comes up here like so. This river goes like that, and pretty clearly the water is flowing in this direction in these rivers. This river, it flows in this direction, and here this is the headwater of this river, so it's flowing in this direction. So once we know that, we can then turn to the groundwater, and we assume that the groundwater has a similar kind of gradient. So we're expecting the groundwater to be flowing towards the lake and also to be flowing towards the rivers, because these are likely gaining rivers. So to draw in the contours, you can see they're in here in red. What I did was to first determine the contour interval, and so I looked around, and the maximum I could find was 900 up here. The minimum was 580, so I decided to go with contour intervals of 50. That gives me about 8 or 9 contour intervals, which is enough detail so you can see what's happening, but it's not so cluttered that it's difficult to tell what is kind of the big picture. And so what I did was to start with the low end here. This is a lake that runs along this right boundary, and so this is a contour essentially. I'm going to use contour intervals of every 50, and the first one that I'll actually draw is 600, but I have to treat this lake edge as if it is a contour, so I can't have my contours touch it. The first one that I draw is 600, and what I do is go along here and look at the points and find where 600 goes between the points. So this is 580, and here's 654. So 600 goes right in there and right in there, and it has to point upstream as it crosses the stream, and comes in here. It's got to be between 560 and 660, and right here, and you can see right there and right there and right there, I've put in tick marks. There's one that mark the place where the contour comes through. So I put those tick marks, interpolating between the points really just by eye, and then I go ahead and draw it, and I hit those tick marks. There's one right there, and draw it in. In this case, I make a fairly substantial V upstream here. They're not really the control points, but I'm inferring that the groundwater contours go upstream like so and wrap around this depression. So this is the lowest point right here at looks like 527. These points are below the level of the lake, and so we have a closed contour here. And this is likely, in fact, almost certainly this is a pumping center of some wells that are drawing the level of the piezometric surface down below the level of the lake. You can also see, as I drew this 600 contour up here, that I took care to go between 580 and 614 right here without touching the contour. Some of you drew this contour, the 600 contour in, and just had it end right here. Well, you know, it can't touch the lake because that's at 580. So then I drew in the rest of these. This one, 700 contour, has to go through this point and V upstream. So actually, the point on the V ended up there. Probably it shouldn't actually look like that. It should maybe come up like that, point upstream a little bit more than that. And this one does too. This one, I drew this in pen, so I really didn't have the opportunity to erase it, but what I wanted to do is have it V upstream like that. And then you can see the tick marks that I drew in to mark where I was going. There's a high right here that's a recharge area. And some of the difficulties that people had was they disregarded these lakes when they drew the contours. These lakes, this lake, and this lake. So you can't have the contours cutting across these lakes. Another problem that folks had was with 850 here as a closed contour and this 850. If you go and look at the points, it's really not ambiguous about where this contour goes. 850 has to go between these points, and so on. But some people saw 850 over here and 850 over here and tried to connect it, and what happened is that 850 kind of meanders around. Well, you can tell that 850 can't do that because of the points here, but also it ends up being a problem if 850 crosses this stream here more than once. So it's crossing this stream, and then this stream is going down like this, dropping in elevation. So it's going to be a mistake if this contour were to say cross over here, because then the water would be flowing in this direction, but it would cross back over the contour. That would mean that the stream would have to be flowing uphill. And so that's not a likely interpretation. Okay, so here is the contours that on the map that I hand drew, and it's pretty straightforward. You can see the tick marks that I made. The problem with the contouring arose right in here. I think what you do, if you follow 460 along, it has to come between these points. It's between these points and these points and these points and these points. So if you put the tick marks in there, you see that it has to do that, but it also is right here. So because it's right here, and we also see that it's got to be between this point and this point. So there's another tick mark here. And between this point and this point, there's another tick mark here. So the way to resolve this is to have a closed contour of 460 and have another contour of 460 that wraps around here. And what that means is if we start at the lake and go uphill, up the piezometric surface, then this is like a small ridge, and we drop down into this drawdown cone that is that's where this well is. Okay, so the main thing that people had difficulty with here was the flow lines. If we start off a point at really almost any point in this flow, essentially really any point, we start off and track it through the flow system, then it will really just have one flow path. And here this one is going along this direction, so it's crossing perpendicular to the equipotentials, to the head contours, and going into this well. This one goes down in this direction. The gradient is determined as the distance measured perpendicular to the contours, and that distance is measured using this scale, and then the change in head, which in this case is 460 to 470, so a change in head of 10 and a distance along that length of looked like about 1,000. Okay, and then also I indicated on here the discharge zones. The groundwater is discharging to the streams, to the lake, probably to the upstream side of this pond right here. It's being recharged up here at this mound and on this island, and maybe in other places, maybe up here, but it's not really clear up here. It could be just flowing through. So really the places where it's clearly being recharged are here and here. And then this problem, this one, really the key to this one is to see how you come up with the heads at these points. And the way to do it is to just recognize that the water level measured on this scale applies to the screen at this point. That gives you a series of points. You can get more points by going to the water table, which we see here indicated by this triangular symbol. And the pressure head on the water table is equal to 0, so the total head is equal to the elevation. So here 36 is right there. That's the elevation of the water table, so that's the total head measured using this datum. So we get these points here, and then we can just contour it using the regular rules. And so 20 comes in like this. And what I recognize here, I don't really have points over here, but I see up here that the water table goes up and then back down. So this is a groundwater divide, and so the contours are going to come back up like this, because right here actually there's no flow, no horizontal flow. And on this side of the divide it's going down and then curving like this, and on this side of the divide it's going down and curving like that. So we draw in the equipotential, the head contours, the 5 contour wraps around underneath like this. This is, if we go and draw in the flow now, it's perpendicular to these contours, it comes down, and if we started, say, right here, we would get a flow line that goes perpendicular like so, and then curves around and has to be coming up here to cross this equipotential where it's perpendicular, and then comes up and then discharges to the stream.